Ryan Reynolds here from Mint Mobile. With the price of just about everything going up during inflation, we thought we'd bring our prices down. So to help us, we brought in a reverse auctioneer, which is apparently a thing.
Mint Mobile Unlimited Premium Wireless. How to get 30, 30, bit to get 30, bit to get 20, 20, 20, bit to get 20, 20, bit to get 15, 15, 15, 15, just $15 a month? Sold!
Give it a try at mintmobile.com/switch.
$45 up front for 3 months plus taxes and fees. Promo rate for new customers for limited time. Unlimited more than 40 gigabytes per month. Slows full terms at mintmobile.com.
Families have a lot going on. Let Ollie help manage the mental load with new cognitive help supplements for everyone 4 and up, like delicious Lolly Focus Pops or Lolly Mellow Pops for kids. And for parents, try 3 new Brainy Chews to help you focus, chill out, or get energized. Find these cognitive health buddies for the whole fam at ollie.com. That's OLLY.com. These statements have not been evaluated by the Food and Drug Administration. This product is not intended to diagnose, treat, cure, or prevent any disease.
Hey guys, welcome to this week's podcast episode. I've got a very interesting guest with me today, James Walker. He is the CEO of NANO Nuclear Energy. He's going to talk all about what the company does, and we're going to talk about different innovations in microreactors, energy. It's going to be an interesting conversation and hopefully enlightening and learn. So, James, welcome.
Well, thanks very much for having me, Christopher. Pleased to be here.
Yeah, so kind of set the stage and talk about you, your company. I know your partner Jay was here. What do you guys do, and what is your company about?
So my background is as a nuclear physicist, nuclear engineer, and I used to work for the UK government in nuclear fuel reclamation and the manufacture of reactor cores for submarines, as well as working as a physicist in the design of reactors. But how the company actually started is that I'd moved away from nuclear into capital markets, public companies, and that's how I met our founder, JU. And when we started the company, we knew energy was going to be a big concern for future markets. And so there was an objective, practical assessment of the whole energy market. That included geothermal, wind, solar, everything. But we saw that it was very likely that nuclear was going to be the energy system that won out over everything. And that was because it was the most consistent form of energy. It was zero carbon emitting. It could be placed anywhere and it wasn't locationally dependent. And there's an abundant amount of fuel, and it's just the reliability and the safety. But when we began looking at the nuclear energy space, we realized that actually the largest potential market was very undeveloped, and that was in microreactors. And the reason why we thought this was the largest potential market was because there were certain areas of industry that were exclusively powered by diesel without any competition. There were sort of things like remote habitation, mining projects, remote oil and gas, military bases, and then blue sky, things like charging stations for EV vehicles, powering data centers. And from that fell out our ambition to build microreactors. And when I say microreactors, just for your listeners, that means anything that produces less than 20 megawatts of power is considered microreactor. Anything bigger than that is a small modular reactor. And so we built up 2 very prestigious teams that draws world-class experts from around the world. University of Cambridge-based team that's working on the Odin design, and a group of scientists and engineers and professors out of University of Berkeley that are working on the Zeus reactor. And so that's really how we began our operation.
Yeah. And so, kind of talking about innovation in microreactors, NANO Nuclear Energy is at the forefront of developing advanced microreactors like Zeus and Odin. And how do these reactors differ from traditional reactors in terms of design, efficiency, and safety?
So there's never been a commercially launched microreactor. And there's not even been a licensed one. This is a new area of the nuclear industry. And but it's been made possible by advances in material science, by nuclear technology. And so why this differs is that when you shrink down a reactor, it gets much more safe because the parts that involved become far fewer and fewer. So you get to the Zeus reactor as an example. that reactor has stripped out the coolant, the pumps. It's stripped out the pressurizer. It's reduced it essentially almost like a nuclear battery where uranium gets hot. It thermally conducts the heat through a solid core, so it doesn't even have a coolant, and just a normal air circulation removes that to a turbine. It's arguably the most basic you could possibly make a reactor. Even if you want to call it a reactor, it's essentially a battery. But it means that for the first time in say humans' energy journey, that we can have something that could produce power for 15 to 20 years, and we can just put it there, and it doesn't need refueling or anything like that. It doesn't even need much staff maintenance. It could have a couple of people at site, and it could produce power for remote communities of 1,000 people, 2,000 people, or island communities. They currently run on polluting things like diesel. This might even have the potential to nuclearize maritime, for instance, by replacing bunker fuel with reactors that can then power ships. And then you would need far simpler ships with far fewer mechanical parts. That would need far fewer logistical considerations for things like refueling. They could just move around the sea for 10 years. So that's what we're going for, and that's why these things are very different. It could be a real game changer in the energy space.
Yeah, and so the role of I hope I'm pronouncing this right, HALEU energy fuel. It's a subsidiary of NANO Nuclear. It's working on high assay, low enriched uranium fuel fabrication. And how does this contribute to the overall efficiency and safety of NANO Nuclear's microreactors?
So what happened when we were building up these microreactors? Because we were coming at this from a very business and commercial point of view, and with an eye to selling these things as commercial products, there was a practical assessment of all of the limitations and the impediments that would stop us taking our microreactors to market. And one thing we quickly identified was that the fuel for a microreactor, the infrastructure and the life cycle of that HALEU product was not in place. So we realized that we needed to become involved in almost like the national conversation about how these future reactors were going to be fueled, how the fuel is going to be generated, how it's going to be fabricated, and how it's going to be delivered to customers. And the HALEU energy fuel was established principally to construct our own fuel fabrication facility. And that was one, to produce our own fuel, but we saw this as a potential opportunity and a big business opportunity to produce fuel for everybody's small modular reactor and our microreactor. Because the difference between conventional fuel that has powered big civil plants and SMRs and microreactors is that if you shrink the microreactor and the SMR right down to a smaller amount, you can put a more highly enriched fuel into the reactor much more safely, and that allows for power generation for a lot longer. And so that's what HALEU fuel is. HALEU fuel is fuel that is rich to upwards of about 19.75 uranium-235, whereas a civil reactor would be enriched to something like 5%, 2 to 3%, maybe 5%. And so there's a big difference in enrichment. And so NANO wants to be part of that national conversation and national solution to supplying this fuel for the next generation of nuclear reactors.
And moving on to environmental and regulatory challenges, what are some of the key environmental and regulatory challenges facing deployment of microreactors like those developed by your company, and how is your company addressing those challenges?
So it's interesting because with microreactors, this is something that the regulators have, they know what they are now, they're familiarizing themselves, but they've never licensed a microreactor. And so considerations that the regulator needs to make needs to consider environmental and regulatory challenges. Now, the principal challenge for a microreactor is that these microreactors could be produced in their hundreds, if not thousands, on a yearly basis, and they could be shipped anywhere. This is the advantage of this, that you could put them in the Antarctic, or you could put them in the desert, or you could put them in a small little Canadian town in the middle of nowhere that's separated from the grid by thousands of miles. But if you're doing that, then the regulator needs to consider all sorts of safety factors, like are we going to allow the microreactor to ship to places with certain seismic activity, with certain temperature differentials? And then this is the new framework that needs to be built up to allow microreactors to deploy. So we've engaged with the regulator, we've made them aware of what we're doing, and we've even reached out to government sources as well to try and bring up certain introductory frameworks to allow for the deployment of microreactors that will basically create almost like a criteria that each microreactor has to meet. So provided it does meet certain criteria like seismic and temperature and flooding risks, then the microreactor can deploy there, and you don't need site-specific regulatory approvals. And that would allow for the transformation of the energy sector, because then you can put microreactors anywhere where there's energy requirements. Desalination plants in the middle of an African jungle, or medical facilities in the middle of the Sahara. It could be anything like that.
Yeah. And it's very interesting. The other question is, as we, a lot of companies, they require collaborative research and development, and discuss some of the collaborative projects you're involved in and how these projects are driving innovation in the field of nuclear energy.
So the important thing with what we're doing is that we're happy to admit that we don't know all the answers, and we're very happy to reach out to the world's best. And so the scientific teams we brought in for the microreactors alone, drawn from, as I said, principally engineers and scientists out of the University of Cambridge on one microreactor, and engineers and scientists drawn from the University of Berkeley on the other microreactor, is that we went out and we found the world-class engineering teams that we needed, and we brought them in, and we obviously incentivized them, and we gave them real freedom to, which obviously you can be very constrained in an academic environment or any sort of research activity. And we just said, you guys know how to make this work. We're happy to work with you as you develop something that you believe will be best. And obviously we gave them the constraints, like we want this to be shipped within an ISO container. It needs to be a certain amount of power, it needs to be a certain amount of safety, and it needs to be inexpensive components and mass manufacturable. That was pretty much the MO we gave them, and they got to work within that. And collaborative efforts on things like our fuel fabrication facility. Again, we reached out to reputed design teams that were involved in the construction and design of major nuclear capability infrastructure. And again, we just said, we just want to employ you to do certain things. This is the output we want. This is the input we expect. Go to it. And so the collaborative efforts have essentially been reaching out to who we believe is the best and bringing the best in to do what they do best to produce these products. So we can finally, when we go to market, we have the best commercial product. And it's actually a great pleasure to work with all these world-class experts as well along the way.
Yeah. And finally, as we conclude, your vision and future projects for nano nuclear energy, the long-term goals, how do you plan to achieve them, and how do you envision the role of portable clean energy solutions in future energy markets?
So NANO is a very ambitious company. On the microreactor front, what we envision is in the early 2030s, if not 2030, we want to have a manufacturing facility that's producing hundreds of these microreactors a year. And the anticipation is that would start with the North American market. We would like to see microreactors involved in the electrification of the vehicle system. So there would be charging stations for EV vehicles in remote locations everywhere, and that would solve a lot of the range problem that you can get with, say, driving between cities. We would like the microreactors to be involved in data center power, because at the moment, data centers and AI centers use enormous amounts of energy, and nuclear could really reduce a lot of the fossil fuel usage that goes into supporting these remote locations a lot of the time. On the fuel fabrication and the nuclear infrastructure side of things, our vision is to create a national manufacturing capability that's supplying the nuclear industry, for private companies, public companies, but also for Department of Defense if it needs it, the Department of Energy, or the National Laboratory System. And so we've got big plans worked involved, and we also anticipate being involved in fuel transportation and also other capabilities which I'm not allowed to talk about at the moment, but we're going to build them up over the next couple of years. How we're going to achieve that is that we're in a very fortuitous position in that because a lot of the executive management of the company have a big background in public companies and capital markets and raising cash, we are better funded than a lot of organizations, and that has allowed us to move a lot faster. And I think one major impediment for a lot of very, very good nuclear companies has been that they can be very grant dependent. And that means that they can work up to a certain point and then they wait for money to come in. And that can really damage not the credibility, but the momentum of that company and lose people. And we won't suffer from that. We can really push on very hard and quite aggressive. And so we'll push on like that until we achieve all of our vision for the company.
Yeah, fascinating. And how can people find out more about your company and what you do?
So you can visit our website. That's nanonuclearenergy.com. You can also find us on Twitter and Facebook. But visit our website and you can sign up for the company newsletter as well.
Excellent. Yeah, and thanks. Let's thank James for coming on. We could probably have him on a webinar for this new technology. It'd be really interesting, and the work that he's doing is really interesting. And thanks for coming on.
No, thank you very much, Christopher. Thanks for having me.